Hello again and welcome back to Physics in Montana 403. Today I want to show you how we measure force in lab. The first thing I'm going to show you is something called a spring scale. It's mechanical, sorry about the glare on it. It's got an outside housing of glass or plastic. And on one side it measures in grams because it's been calibrated to work on Earth. And on the other side it measures in newtons. You'll be able to see that there in spite of it. So it moves up and down according to how much force is applied to the spring that is connected to a hook at the bottom. So if I want to measure the mass or weight, because I can get both off of this spring scale, of something like this tangerine, I'm going to put it in a little produce bag and hang it from the hook. And when I do that, the spring is pulled down. And so you can look on there and see the reading on the spring scale, at least you can if you're here in person, and figure out just how much weight that little tangerine is supplying. A newton is not very big. So an apple, a good-sized apple, is typically about the force or weight of 1 newton. How would I weigh a book? Because a book is going to be in your lab today. So one of the things I'm going to do is put a string inside the book, and then I can hold it up like this from the spring scale. So if I use the spring scale to hold it up, I can get a reading on it. Spring scales come in different sizes because you can damage the spring if you use too much force. Because if you've ever had that sad experience of breaking your slinky, you know that too much force can damage a spring. So you choose the right amount of stiffness or stretchiness of the spring to go along with the weight. Now, that's kind of the old school mechanical way to do it. A more modern way to do it is to use this force sensor. So this is digital or electronic, and it's made by Vernier, the people who make Logger Pro. And I have it connected, remember, to a lab interface so that the computer can help me with it. And the first thing I have to teach the computer to do is understand what the sensor is reading. So I need to calibrate the sensor. So I'm going to go in the program. Sorry, I waited too long and the computer closed in on me. I'm going to go into the program and I'm going to choose calibrate. I realize the screen is pretty bright and hard for you to see. But when I do that, I have an opportunity to go to experimental setup, or in this case, data collection. So experiment, calibrate. So experiment and calibrate. And I'm going to hold it vertically with absolutely no weight on it. And I'm going to tell the computer this is what 0 looks like. So I do that and I enter a value of 0. And if you're going to calibrate something, you need more than one number. So I told it that was 0 because I don't want to pay any attention to the weight of the hook. You can see this thing has a little hook on it, just like the spring scale does. So I'm going to put a big mass on it. In this case, this is 1/2 of a kilogram. So what would that weight be? Can you tell me? Okay, so that's going to be 4.9. 4.9 newtons. I'm now telling the computer. So I try to hold really still, and I hit keep. And now my sensor understands with good units. Understands is kind of an anthropomorphic or silly word, but the idea is calibration is an important step. So now I can weigh the book using this scale. So I put the string in the book, and I lift the book with the string because I'm interested in figuring out what the normal force is. So whatever force it takes for me to hold the book up is going to be the same as the force it takes the table to hold the book up. And I think it's important, don't you, that I hold it with a certain velocity. So think about that. How do I have to hold the book so that my lifting force will exactly equal the weight force? So when I'm doing that, I can see the reading over there on the computer. So I'm going to take pictures of the computer screen for you and show you things like the weight of the book and also the weight of this dangling metal plate that I weighed from a string the same way as I did the book. Because these are two objects I'm going to drag, and I'm going to drag them across 2 different surfaces to see what's happening with friction. So one of the surfaces is a non-stick rug pad. It's a fabric and it's very rubbery feeling. And it's designed to go on the floor and increase friction so that if you have a throw rug, you don't slip on it. The other surface I'm going to use is just our smooth black lab table. So I'll put the book connected to the force sensor by a string, and I'll drag. And I'll be careful that my pull is horizontal because we don't want to have to deal with any components we don't have to. So perfectly horizontal pulls. So you're going to work on this lab in order to understand friction, how we measure force in lab, practice your free body diagrams and net force equations, and learn about the 2 coefficients of friction. Thanks. I hope it works.